Okay, division is a little bit specific. So here was the last program we were working with mathematical operators. I'm just going to clear this out, empty this out, and start again. So let's say I declare two integers, x and y, right? And I give the 10 to the value of x, and I give 5 to the value of y. And I want to divide those, right? So result, right? Okay. So I'm going to divide those two. I'm going to say result equals x divided by y. Now, when I divide 10 by 5, I should get 2, right? So let's print it out, right? System.out.println result is plus result. Okay. Now 2 should come out here when I run this program, right? So I'm going to run it, and I get result as 2. Now, here's the slightly confusing part. This is integer division because both of my variables are integers. So when you use the slash sign with integers, Java uses integer division. So for instance, if I said y was 6 here, and I divided 10 by 6, you would expect to get a decimal value because 6 is going to go in 1 point some amount, right? However, Java is not going to treat it that way. Java is going to say, well, this is an integer, this is an integer, you must mean integer division, and it's going to say, how many full times or how many whole times does 6 go into 10? And it's going to say, well, it goes in once, one whole time, right? So if I run this, I get 1, right? And this is the confusing part to people because it's considered integer division if the two operands are integers. Okay, so you have to keep that in mind. So this is really saying how many whole times does 6 go into 10. So for instance, if I made this, 15, x 15, it would say how many whole times does 6 go into 15, and the answer would be 2 because it goes 6 times 2 is 12, 6 times 3 is 18. So if I ran this, I would get 2. Same as if I made this 16, right, and ran it. I would still get 2 because 6 goes into 16 2 whole times. Now, how do we get it to give us an answer that is not integer? The way you do that is you make one of the two variables, the x or the y, a double or a float, right? So instead of making the y, for instance, an integer, I'm going to declare y as a double, and I'm going to assign 6.0 to it just to make it clear in my assignment here that that I have a double or a floating point number. Now, this is giving me an error, and the reason it's giving me an error is because I'm trying to now store floating point division into an integer. So I can no longer have the result be an integer. The result also has to be a double. Okay, so now when I print result out, it's going to tell me exactly how many times 6 goes into 16, right? And I run it, and it goes in 2.66666, right, times, right? So as long as one or more of the variables you're dividing is a floating point number, you will get a floating point answer. When both of them are integers, you're going to get integer division. Okay, now there's some tricky ways to get around this. Let's say your x and your y were both integers, right? They are both integers because in your program you really want them to be integers, right? But you want to be able to divide them and see the actual amount. Now, if I divide them like this, right, 6 divided by 16, we've already done this. We get 2 because it's using integer division. The x is an integer, the y is an integer. Now, let's say, however, I wanted to force this division to to be floating point division, right? What I can do, and this is one of the few times this concept is used in beginning programming and acceptable, is I can force one of these variables, x or the y, to be a different type just for now, just for this operation. And the way you do that is you put the type of the variable you want x to be just for this one specific case. So this right here is typecasting x, which was an integer, to be a floating point number, 16. And I could have done it to the y also. I could have done it to the y or the x. Only one of the variables has to be floating point to use floating point division. So now when I divide these, even though x is an integer and y is an integer, right, as declared, just for this one time, the x is going to be used as a floating point. So now the division symbol is going to use floating point division, and I get 2.66666, right? Okay, so we get that. Now, again, typecasting is useful in more advanced programming. This is pretty much the only time it's acceptable to use in beginning programming for integer division, to force it to be floating point division. Now, let's go back here and declare our x and y and even our result as integers, right? And let's see what happens again to get back into this. So now we're going to be using integer division again. 6 goes into 16 2 times fully, and we get result of 2. Now, sometimes with integer division, it's useful to know what the remainder is, right? How many are left over? So 6 went into 16 2 times, right? That's 6 times 2 is 12. But the remainder is 4, right? 12, 13, 14, 15, 16. The remainder is 4. And sometimes it's useful to know the remainder. Luckily, Java and most programming languages have an operator to find the remainder. So I'm going to declare our remainder variable. And the way you find the remainder is you use the modulus symbol. And the modulus symbol is the percent sign. So what does this say? This line says x mod y. That means divide y into x and tell me what the remainder is. So this is going to say 6 goes into 16 2 times fully, and the remainder is 4, and it's going to put that value of 4 into the variable remainder. So if I print that out, by the way, I can copy and paste lines like that, right? Okay. I could say remainder is remainder, and it would print out 4 for the remainder, right? The remainder is 4. And this symbol, this percent symbol, is called the modulus, right? And we would typically read it off as saying x mod y. Most people are not going to say x modulus y. They'll say x mod y. And it's finding the remainder. So if this was 12, right, the result would be 2 because 6 goes into 12 2 times. And the remainder would be 0 in this case because there is no remainder. It went in evenly. And if I run it, I see that the result is 2 and the remainder is 0. If this were 13, right, the remainder would be 1, right, and so on. So again, a review of integer division and a review of modulus, as well as how to force floating point division when you're dividing integer values.